Hi friends, welcome to the Unit 3 Day 4 notes. Specifically, we're going to get into the attributes of polynomial graphs with zeros of multiplicity. So in this particular example here, we're talking about two different types of graphs. We have f of x equals x, so that's the light colored one, and then g of x equals x cubed. Note that both of these graphs, the function crosses through the x-axis, and this is because this is an odd power exponent. For each of these, that it crosses through that particular point. So this, when you have an odd power exponent, you will always intersect or cross through the x-axis. And then when you have an even power, is we have a situation where we bounce. So in this case, f of x, the x squared is the light one, and then the g of x, x to the fourth, is the darker colored one. And so these will bounce against the x-axis. So they touch and then they go away. Example 3. So here we want to find the degree and then describe the end behavior and name the y-intercept of the graph. For this particular one, to find the degree we have to do a little bit more work. I don't need to multiply the whole thing out. I just need to know the leading degree. So if I think about this particular quadratic, it's a quadratic, and I know a quadratic's leading degree is going to be x squared times a linear x squared times x. I know this is going to have an x cubed leading degree, and I know it's going to be positive because these numbers are all positive. So x cubed is a cubic leading degree. So that tells me cubic with a positive leading coefficient. So that tells me that's going to go down and then up. And then for talking about the end behavior down and up. So this is as x approaches negative infinity, your y, or I'm going to switch over, also it's called f of x approaches negative infinity because it's going down. Sorry, that was written very poorly. Negative infinity, there we go. And as x approaches infinity, your y, or your f of x, is going to approach infinity because it goes up. This one we have to do, again, a little bit more work to find the y-intercept. If I think about this part with a quadratic, to get my last term, I need to take 2 and then squared. Oh, where's my other pen? Switching colors. Hopefully you can see it. 2 squared. Yeah, it's kind of different. And then times negative 3. Because the value here is negative 3. 2 squared is 4. 4 times negative 3. So that would give me negative 12. So then my y-intercept for this one is going to be 0, negative 12. For the next one, the degree of this one, again, looking at all of the powers. So here we have an x squared. The negative is out in front. Be mindful of that. So the negative isn't inside the parentheses, it's actually out in front. So that's going to be a negative x squared times an x squared times an x. So I multiply all these values together. I'm going to get x to the 5th, and it's a negative x to the 5th. Knowing that it's negative helps me determine that it's an odd power with a negative leading coefficient. So this is going to be up and then down. So as x approaches negative infinity, your y value, or your f of x, approaches positive infinity. And as x approaches infinity, your y value, or your f of x, approaches negative infinity. Same idea that we did earlier to find the y-intercept. So we have 1 squared, and then we're going to have that negative. Again, that negative's out in front. So be mindful, I didn't put the negative in parentheses and square it. I put the negative here because the negative is out in front here. So be mindful. Times 3 times negative 6. So 1 squared is 1. Negative 1 times 3 times negative 6. So that's going to be positive, and then 18. 6 times 3 is 18. So positive 18. So my y-intercept is going to be at 0, 18. All right. Join me in the next video as we talk about the graph of the polynomial function and how we can just look at this here and just discover a lot of things about the graph before we actually graph it. Have a good day.